So this is zooming in on Plato, and if you look at the painting, he's pointing up. He's pointing to heaven, he's pointing to the realm of the ideal. And for Plato, this is absolute reality. And everything that we see on a day-to-day our physical life is really just a shadow of this higher reality. And so you see him pointing up. He's also barefoot, and this is indicating his detachment from worldly things. He kind of floats above the world. And so this is Plato's philosophy. And he had a student, Aristotle, who had a quite different philosophy. So here we have Aristotle, and you can see the difference in the symbolism in the painting. His hand is outstretched, and he's interested in what's right in front of him, the physical world. He's wearing sandals. He's not just kind of floating in this ethereal realm, but his feet are on the earth in front of him, and also he's wearing blue, kind of a color of the ocean, and he's wearing also brown as well, color of the elements, whereas Plato is wearing this purple and this red, this more fiery kind of thing. Anyway, so this is all the symbolism in the painting. But anyway, Aristotle was the first to really start tackling the questions of physics, and this is all the way back in 300 BC. But he didn't do it right, and we'll talk a little bit about Aristotle's physics. But in any case, he's a great contributor because he recognized the importance of observing the physical world. Let's talk a little bit about some of Aristotle's observations. Aristotle was the first to classify animals, and this was a big advance in the sense that classification is a big part of science. It's not just categorizing stuff. You have to look very carefully at the relationships between things, and I can read from a little excerpt from one of my favorite books about it, and it talks about Aristotle, and it says that Aristotle was the first to formulate the general logical principles of classification and founded the subject as a science. His method employed many of the principles which are still used by biologists today. He was, for example, well aware of the importance of using more than one characteristic as a basis for identifying classes and so on. So this goes into biological classification. It says that there are 500 different species and put them into his classification scheme. And his scheme was basically 4 major subgroups of those possessing blood, and he goes into all these different things. And now his classification scheme was pretty good. It's not exactly what is used in modern biology, but the point is that he was thinking about these things and really starting to do them. Now this is one branch of science. The other branch of science where Aristotle started thinking about was explaining physical phenomenon, and this is where he did a really bad job and got it wrong, but his contribution is to the fact that he was thinking about it at all. So let's look at some of his physics. So to give an example of where Aristotle got it wrong, take a look at his periodic table of elements. You have earth, water, air, fire, and the mysterious 5th element, which is the ether, which, by the way, persisted as at least an idea into the 20th century, but was tested and shown to not exist. But we can look at these ancient understandings of the world, and obviously it would be an immature or not correct response to just laugh at it and say, "Oh, it's wrong. Haha, they weren't very smart." No, that it's just the opposite. Aristotle was looking at the world around him and trying to organize it into some kind of overarching principle. Obviously, the details are vastly incorrect, but that's okay. It's the idea that counts. It's kind of, the saying, it's the thought that counts. And what he was doing right was trying to organize his observations of the world into one coherent system. Another area where Aristotle's physics was wrong was in his take on motions of objects. Basically, he would just come up with his best guess at the answer as to why something behaved the way it behaved, and then write it down. So he's missing a key element in science, which is experiment. So even though Aristotle was interested in classifying and organizing the things he saw in the physical world, he had no understanding of performing an experiment. And this is obviously a key part of the scientific method. It's one thing to come up with a hypothesis, but it has to be tested experimentally. And so this is where the history of science runs into a bit of a logjam, because what Aristotle's contribution was, he wrote a lot of physics down. For example, he talked about, and I'll bring up another slide. Let me show you a little bit of Aristotle's physics. So here's an example of some really bad physics that Aristotle did. He was trying to explain why an arrow would continue in its motion through the air. And so he said that as the arrow went through the air, it pushed the air aside at the tip of the arrow, and that air circulated to the back of the arrow and pushed it from behind. And so basically this circulation kept the arrow moving in a forward direction. Now, again, the good thing is that he's thinking. The thing that's not correct is that he's not doing any kind of experiment. So, anyway, Aristotle developed a very vast description of physics, and that description included, of course, the idea of a geocentric or Earth-centered universe, and that, of course, is not correct. But again, it takes a lot of study and a lot of scientific development to show that the Earth is indeed not the center of the solar system, and we'll get to that in a little bit. So, to summarize the ancient Greek contribution, you had Plato, who is describing a mathematical ideal, and Aristotle, who is observing the world, classifying, and trying to explain what he sees around him. And these are two different poles of understanding, meaning they're not necessarily opposed to one another, but they're very different. And what happened was, in the West, the Roman Catholic Church adopted Aristotle's teachings as correct, and consequently, very little scientific development happened for about 1,500 years in the West. In the East, on the other hand, Aristotle was never adopted that way, and more happened, but then there was a lot of suppression from the Turkish Empire. So there was the Greek culture kind of went underground, and so not a lot happened in the East. And so for about 1,500 years, the development of science as we know it today was stagnated. But then things started to happen, especially with the development of better optics and with more careful study of the heavenly bodies. So we'll get to that in just a minute. We're going to end this particular section of this film, or this webinar or whatever you want to call it. And then so click on the next link and watch the next video. We'll pick it up from there.